Hello scientific audience, how are you all? So today I'm going to explain you the applications of Newton's laws of motion through a very simple problem. So if at all you do not know the Newton's laws, not to worry about. The first law of Newton is displayed over here. So it states that an object would continue to be in its own state unless an unbalanced force acts on it. So what is the meaning of this particular problem? What is the meaning of this law? Let's understand through this easy problem. So here is a ball and the mass of the ball is taken as 10 kilogram and the ball is at rest. So if the ball is at rest, its velocity is 0 meters per second. And I'm going to assume the system over here as the ball and the surface over here to be frictionless, right? So in this particular case, this ball is acted upon, same ball is acted upon by 10 Newton forces from both the sides. So both the forces would actually cancel out each other. So a pair of balanced forces are acting on the system. So Newton's law states that if the balanced forces are acting on the system, these two forces will cancel out each other and these two forces will have no role on the state of this particular ball. So this ball was at rest. Now it will continue to be at rest and its velocity will be still 0. So no effect of these two forces over here. Right. Now here is an unbalanced force acting on this ball. Now we can understand that this is a larger force and this is the smaller force comparatively. Now suppose that time is equal to 0, these two unbalanced forces are acting on the system and the net force will cause this ball to accelerate. You can just understand that since the net force is acting on the ball in this direction 10 newtons, because this is larger force, this is the smaller force. So this ball will move in the direction of the larger force and this ball will accelerate in this direction, and we have considered the surface to be frictionless. So here comes the Newton's second law application, that what will be its speed after every second, that would be understood with the help of second law of Newton, which is displayed on the screen. So guys, I will not go in the depth of the Newton's law over here, but essentially the last part of the Newton's second law states that net force acting on the system is equal to mass of the system multiplied by the acceleration produced. Now I would like to make a point over here that this equation holds for one axis. Suppose you can calculate the net force on the x-axis and you can apply this entire equation on x-axis. You can even apply this on y-axis as well, right? But here we are going to apply this equation on the x-axis because the motion of the ball is along x-axis. So we must not have a confusion that the weight of the ball which is along the downward direction is going to affect our equation. No, because the motion of the ball is along x-axis, so we are going to apply this equation along the x-axis. So we know that 20 Newton in this direction, 10 Newton in this direction. So what should be the net force acting on the ball? So the net force acting on the ball will be 10 Newton in this direction, right? Because this is the larger force. Now this 10 Newton force is acting on this ball whose mass is 10 kilogram, right? So these are identical balls. So this is the ball whose mass is 10 kilogram, and I can draw a situation where 10 Newton force is acting. This is the exact replica of this particular situation because 20 minus 10 is 10 Newton, right? Now what is going to happen? Let me apply this formula over here. So F net is equal to mass of the ball times A. So F net is 10 Newton. That is equal to mass of the ball, and the mass of the ball is 10 kilogram times A. So this goes in the division and finally we will get the acceleration as 1 meter per second square. I would also like to make a point that acceleration and the force, they have same direction. So the direction of net force is same as the direction of the acceleration. Now acceleration means the velocity of the ball will increase. But in which direction? In the direction of net force. So the ball will experience increasing velocity in this direction. And this means that the velocity of the ball will increase by 1 meter per second after every 1 second. And these two forces are going to be continuously applied throughout the motion. It is not like that one time you have applied 20 Newton, 10 Newton and you are leaving it. No. For this acceleration to happen, for this particular situation to happen, these both forces must continuously be applied. So now after 1 second, suppose the ball is somewhere over here, and this is suppose time is equal to 1 second. After 1 more second, the ball will be somewhere over here, because I'm sorry, this is 2 seconds. So this is suppose time is equal to 2 seconds. Now the ball will continue to move in this direction because there is a net force acting on the ball, and that is 10 Newton always. So constant 10 Newton force is acting on the ball in this direction, and this states that the acceleration is 1 meter per second square. So after 1 second, the speed of the ball will be 1 meter per second, because earlier the ball was at rest, initial velocity was 0. And acceleration means after every 1 second, the speed of the ball will increase by 1 second. So again after 1 second, the speed of the ball will increase by 1 meter per second, so it will be 2 meter per second. Again after 1 second, the speed of the ball will increase by 1 meter per second, so it will be 3 seconds, and so on. So this is what is going to happen. Now let's consider the another situation in which the same ball of mass 10 kilogram is moving with a constant velocity of 5 meter per second in this direction. Again, the surfaces are frictionless. Now this ball was already in motion with 5 meter per second, and let's assume that two balanced forces are acting on the system. So basically these two forces will cancel each other out, and they will have no effect on the velocity of the ball. So the ball would continue to move in this direction with a constant velocity of 5 meter per second. But in this particular situation, since unbalanced forces are acting on the system, and again I am assuming that exactly at time is equal to 0, these two forces were acting on the ball. At that time the ball had velocity 5 meter per second. So you can just assume that this ball is rolling, and suppose at time is equal to 0, two forces are acting, and it was already in motion with 5 meter per second velocity in this direction. And now these two forces will constantly act on the ball while the ball is in motion in this direction. So after 1 second, the ball will be somewhere over here at time is equal to 1 second. Then again at time is equal to 2 seconds, the ball will be somewhere over here. At time is equal to 3 seconds, the ball will be here, and so on. And why the ball will go in this direction? Because 20 Newton force is larger than 10 Newton. So net force would be 10 Newton in this direction. And remember that 10 Newton constant force shall always be applied in this direction. Right? But now, since the same calculation, the application of the second law, the net force acting on the ball is equal to mass times the acceleration. So net force acting on this ball is 10 Newton. That is equal to mass of the ball 10 kilogram times the acceleration. So again acceleration is 1 meter per second square in the direction of the net force. That means in this direction. So the velocity of the ball will increase in this direction by 1 meter per second every second. But the velocity of the ball was already 5 meter per second. So an increase in 1 meter per second will be 6 meter per second over here, then 7 meter per second over here, 8 meter per second, and so on. So guys, now let's wind up the class by a small problem. The problem is the ball moves with the constant velocity from here till region B on a frictionless surface. So no external force is being applied. So there won't be any effect on this velocity of the ball in positive x direction till point B. Now the same ball travels on the friction force on a surface having friction force 10 Newton, say, and this frictional force is always opposite to the direction of motion. So if we do not provide any external force, the velocity of the ball is going to decrease, and finally after traveling certain distance it's going to stop. Now we don't want that thing to happen. We don't want the ball to stop. We want the ball to be moving with constant velocity 5 meters per second. So is the work being done by us in this particular situation or not is the problem. So the answer is yes. Now, suppose the frictional force acting on the ball is 10 Newton, and frictional force will be always opposite to the direction of motion. So we will have to exert the same force opposite to the direction of friction. So this is frictional force in this direction on the ball by this ground, and we will have to continuously apply 10 Newton force till the ball travels certain distance which we wish for. So these two forces are going to cancel each other and the ball will keep on moving with constant velocity. So we will have to exert the external force equal to the magnitude of the frictional force and opposite to the direction of frictional force, so that these two forces cancel each other and the ball moves with constant velocity. So since we are exerting the force and the ball travels certain displacement, so the work done by us shall be equal to the force multiplied by displacement. So now let's wind up by just looking at all the three situations once again. In the first situation, the ball was at rest and we were applying the balanced and unbalanced forces. The ball continued to remain at rest in the case of the balanced force application, and when we applied unbalanced force on the ball started accelerating in the direction of net force, and it is to be calculated with the help of the second law of Newton. Now let's move on to the next part. In this particular situation, the ball was already moving on the frictionless surface, and previously also it was moving in the frictionless surface, and the ball was moving with a constant velocity of 5 meters per second. Now if we are applying the balanced forces, then these two forces will cancel and there will be no effect on the state of the ball and the velocity of the ball too. But if the unbalanced forces are acting, then as per the calculation the ball will accelerate, and this is how the velocities are going to change. So hopefully guys you have enjoyed my lecture. Please do comment and subscribe my channel if you have not done so. If you have any doubts, do comment in the comment section. Thank you for watching the video.